In this video, I want to start exploring how we can place trees on our map using, again, Perlin noise function. There is a great video called Discrete Constructs in Endless Worlds on GDC Vault, and I think it is on YouTube as well. And basically, it shows multiple techniques on how you can create things like structures, rivers, but I think it also covers trees, and that's where I get the idea. So, a Perlin noise, when generating a 2D Perlin noise, it has minimas and maximas in local points. So, we can establish that in this terrain, we can see multiple maximas that are local maximas. And the idea is that if we generate a Perlin noise value different from our terrain for our trees, then we can simply split the terrain into chunks, which we already have, then takes the maximum around this terrain, and this would be calculated by simply selecting each point, calculating the noise value, and simply checking if the neighbors of this concrete position are lower or equal value to this concrete position that we have selected. Now, if they are less or equal, then it means that our current point is a local maximum. And if we have those local maximas, then we can simply say, okay, let's place the trees in those local maximas. It will not represent our terrain because it will be a separate Perlin noise calculation, but basically we can integrate it with our world, for example, by preventing the tree being spawned inside the water or at certain height. In our case, I think the only limitations will be that I do not want to place trees on the rock surface. But basically, this is the idea of how we can create our trees pretty easily and place them around the map. So overall, they look pretty nice and placed pretty randomly. I'm sure that there are better ways to do it, but basically this is the whole notion of it, that we can still use Perlin noise, and just by processing the data that we receive for each chunk, we can find the local maximas and place their specific things. So we have handled one of the problems, which is placement of the trees. The second problem is, as you can see, that trees, as far as it goes for the trunk of the tree, it is in one space, so it is possibly in one chunk. But the leaves can be shared between two chunks. So the second issue that we have is that we need to place the leaves, and we are not always certain that all the chunks, so for example that this chunk is rendered. So we need to place the data, but when rendering we need to split the rendering. For example, here this tree is rendered across 4 chunks. So basically we need to put the data about the tree leaves into the chunk data of ours, and then when we are rendering, we are simply rendering trees as well as our terrain in one go. Okay, so this is the issue with the rendering, and we are going to tackle this as well. Okay, we are back in our project. So first of all, we need to adjust our generation, and our generation mainly happens in the terrain generator. So let's open this script up. Okay, great. So in our terrain generator, we have our biome generator. We're going to select the biome generator later on based on what is the biome that we have in this position. But basically, the biome generator should have a way to generate trees if we want to generate the tree data. Now, to avoid the issue of maybe for our desert we do not want to have any trees, we are going to simply have something like this. We want to have a tree data object, tree data equals, and we are going to call our biome generator .get tree data, and we are going to pass here our data, and also we may want to include the map seed offset so that we can generate different tree data depending on the map seed that we have provided in our game. Okay, so now first of all we need to create this class, so let's create a below public class tree data. Okay, and we are going to now be able to generate this get tree data. Right click, quick actions, and generate method in our biome generator. Now we may want to select our public class tree data, right click, quick actions, and move type to tree data script. So this will be in a separate script. Basically, this is how we can quickly generate our logic. And when we have this tree data, we may want to set our data dot tree data equals our tree data that we have calculated. So we are going to store the data in our chunk data about the trees. This is exactly because later on when we are rendering our chunks, we need to include only the leaves that are visible on this specific chunk. So this is why we need to have this data before we can render our world. So let's right click on this tree data quick actions and generate field tree data in our chunk data class. Okay, and now we have saved this data. So now later on when we are processing our columns, we are going to be able to include this tree data in this generation. Just to clarify, we have put this code before those two for loops because we only want to calculate the noise values once, and then when we process our data, we want to check the data against what we have calculated in each position. But we do not need to regenerate those values, we only want to calculate those once. For now, let's focus on how we are going to generate those points using the local maximas of our Perlin noise values. So let's save it, let's go back to Unity. Okay, so somewhere around here we should have the tree data. So I'm going to right click, create a new folder, let's call it trees. Okay, I'm going to drag here our tree data, this new folder. Okay, and let's open this folder up because we will need to have a couple more scripts here. So let's right click C# script and we are going to call it tree generator. Okay, so this will be the mono behavior that will store all the settings for the tree generation for a specific biome. So let's maybe start by filling in the tree data class that we have already created. So let's open it up. Okay, and here we are going to have three fields. Now we can create public list of vector to int, and we need to import the vector to int. So right click on it, quick actions, and using Unity Engine, because when we have generated our class, we have not added any libraries by default, and we need to also import the list. So right click, quick actions, and using system collections generic. And now we are going to have a list of vector to int, and those will be tree positions because they will be independent of the height, also from the basically y-axis in our game. They will be generated by selecting the random position through the Perlin noise. Next, we are going to have also a list, but of vector3 int type, and those will be tree leaves solid. And I have planned to add tree leaves transparent, but I didn't at the end, so we can have only two of those here. And basically, tree leaves solid will be an indicator where should we put the voxel representing our tree leaves, and this will be important for the generation of our different chunks and rendering them correctly. And this is it for the tree data. Let's save it, let's go back to Unity. Great. Now let's open up our tree generator script. Okay. Now this will be a mono behavior because we are going to have to pass to it noise settings and domain warping. So create public noise settings, tree noise settings field, and public domain warping, domain warping. And we are going to use both of those to generate our trees. So first we are going to have a method called public tree data. So we want to return tree data, generate tree data. We are going to take in the chunk data, and vector to int map seed offset. This will be called, I think, from the biome generator script. Now in here, we are going to set the tree noise settings world offset to be the map seed offset so that we can generate appropriate version of our tree positions depending on the offset that the user has provided. Next, we are going to create a new tree data and we are going to create float, so the 2D array of noise data. And we are going to call generate tree noise method. We are going to pass chunk data and the tree noise settings. So right click, quick actions, and generate this method. And at the end, we are going to set tree data, tree positions, and we are going to have a new class called the data processing. And this will be a static class. So let's right click, quick actions, and we can generate a class data processing. Okay, and this has generated for us this class. Next, we have this find local maxima. So we can right click on, actually, let's fill it in before it generated. And find local maxima will take the noise data that we have generated, because we need to have this noise data to be able to analyze it in terms of what are the values of the neighbors of a specific point. Now, when we have this noise data, we need to pass chunk data world position.x and chunk data world position.z values, because basically we are generating this in the x and z direction. We do not care about the y direction at this point when we are generating the positions that our trees might be placed at. So now, if we have passed all of this, right click on this find local maxima, quick actions, and we are going to generate the method in our data processing class that we have generated as a temporary class that we are going to fill in later. And we are going to at the end return our tree data. Okay, so this is one method. The second one, the private one, will be generate tree noise, which will generate as a float to the array of the noise values for each position in our chunk. Now, to generate it, all we need to do is create a new float to the array that will be of size new float chunk data chunk size chunk data chunk size. So this will be our 2D float array. Now we need to calculate x max, x min, z max, z min. So those are the points that are defining the bounding box of our chunk. For those, we want to calculate our noise values. And those will be calculated by getting the chunk data world position.x plus chunk size and chunk data world position.z plus chunk size. And the min and max will be simply position.x and position.z. Now this is because we need to calculate the noise based on the world position in our chunk. Next, we are going to have x index 0 and z index 0. And we are going to loop for each x equals min, x less than x max, x plus plus, and the same for the z. And we are going to call noise max, x index and z index equals. And we are going to call our domain warping to generate our domain noise using those x and z values from those for loops and the tree noise settings. Now we are going to increase the z index and x index so that we can place the correct the value in the correct spot in our noise max array. This is simply because our x and z values will be some coordinates in the world space, but our values in the noise array are from 0 to the chunk size. And we are going to return this noise max array. And this is all that we need to do in our tree generator. Now, last thing that we need to fill in is this data processing find local maxima method. So let's right click on this and go to this definition. Now let's maybe take a break here, and in the next video we are going to fill in this data processing class as well as handle placing our trees on our map. Okay? Again, if you're enjoying this tutorial, leave a like, leave a comment, subscribe to the channel, it helps me a lot, and also you can support me by becoming a patron. Okay? See you in the next video.